Hello everyone, welcome to my YouTube channel Programming with DPwala. Hope you all are doing good. So let's start with the today's Leetcode weekly contest 387 analysis. When we talk about today's Leetcode contest, the contest was relatively on the easier side and all the four problems are doable. So let's start with the very first problem. So here in this problem, the name of this problem is distribute elements into arrays one. Here what we are given a nums array. We need to distribute all the elements of the nums into two arrays, array one and array two. So how we need to distribute? So they have given the condition that if the last element of array one is greater than the last element of the array two, then we need to append our current num into array one, otherwise in array two. So at the start, what we need to do, we need to add the first element in array 1 and the second element in array 2. After that, we need to apply this operation. Let's see for this example 5, 4, 3, 8. So let's say we are having an array 5, 4, 3, and 8. So here in first array 1, what we add 5 as they are mentioned, and in array 2 we add 4, right? After that we are at element 3. So what we need to do, we need to check the last element of array 1 and array 2. As last element of array 1 is greater, so we will add 3 to array 1. Now we are at 8. Now the last element of array 2 is 4 and array 1 is 3. So now last element of array 2 is greater, so we'll add 8 to array 2. And at last what they told us that we need to concatenate both the arrays. So what we will do, we will concatenate. So our answer is 5, 3. First array is this, and that second array is 4, 8. So our answer is 5, 3, 4, 8. So you can see that 5, 3, 4, 8 is our answer. So similarly, the code is here. First, I have put the first element in array 1 and similarly in array 2, second element in array 2. After that, I have checked that whether the last element of the array 1 is greater than last element of array 2. If it's true, means we need to put the current element in array 1, otherwise in array 2. And at last, I have concatenated it and written the original array. So this is a very simple one, and you need to do it in very fast to save your time for the harder questions. So let's discuss the second problem. So the second problem in this contest is count submatrices with top left element and sum less than k. So here we are given a matrix grade and the integer k. So here what we need to do, we need to return the number of submatrices that contain a top left element of the grid and have the sum less than equal to k. Means we need to calculate all the submatrices which are having a sum less than equal to k. So let's see this example, that is 763661, right? So let's see this example 763. I will remove this. Yeah, so let's discuss this for example 763 and 661. 763 and 661, and our k is 18. Means we need to k is 18. We need to find the sum less than 18, less than equal to 18. So let's see. So here we need to start from the very first element, means the topmost left element, that is 7. So we will move in a similar manner. So here what we do, first we will save our this number. Similarly, our submatrices may be this as well, 7 6, 7 6 3 as well. Similarly, we are having 7 6 this column wise, this 7 6 6 6. These are our submatrices, you can tell. So here we need to maintain, or let's say what we need to do, we need to maintain a sum for every submatrices. So you can see that If I have 7, right? If I need to calculate the submatrices of this one, right? 7, 6, this one, right? I will try to create it here, right? This one, 7, 6, 6 and 6, right? So here I am having 7, right? After that, if I need to calculate the submatrices with the sum this, so what I do, I will add 6 to 7, right? Similarly, if I want to add calculate for this, I will add 6 to 7. If I want to add for this entire submatrices, what I need to do, I will do, if I am at this index, right, j, let's say, what I will do, I will take the previous sum from here, because it will store the submatrices with the sum here, and the uppermost one means like this, right? So here the sum is 7 and 16, right? Here 7 and 6, that is 13, right? Similarly for here, for this submatrices, sum is 13, right? So we are having a sum for this and sum for this. What we need to do, we need to add the current element as well. Current element is 6, right? As we can see that 7 is added 2 times. We need to remove it 1 time, right? So our sum is 13 plus 13 plus 6, the current one, and minus, as it is added 2 times, right? We need to remove it 1 time, right? Because uh, let's say I have added here, so I can't add here, right? We need to calculate it for the entire one, right? Sum for, so 7666, right? So it is ultimately, we can say 25 one, so we can't add this submatrix because it is greater than 18. We need to calculate the less than equal to 18. So here this will not be a case. So here the submatrices which are valid are 7, single one, 7, right? Then we have 7 6, which is 13 less than 18. One is 7 6 3. It is 16, which is less than 18, right? So 3 we got from the first row. Similarly, 7 and 6 from the first column, right? 4. After that, as we have checked for this will generate a 25 sum, which is not less than 18. So this is not the one. And similarly, if we take the entire this one, this will be all obviously greater than 18. So it will not be. So our answer is 4. So you can see that here what we need to do, we will maintain a prefix sum. So here you can see that we will be starting from this type of thing, right? This, this. So everything is overlapping, means we can store the previous one and use it in the further elements. Means we can use the prefix sum concept here. Prefix sum is a kind of dynamic programming because we are using a previous calculated value in the current value. So here let's see the implementation. You will get the approach easily. So you can see that here these are the NNM row and column. I have created a matrix. This is the prefix sum matrix which I will be storing. The first element is the grid, the leftmost element. That is here you can see that 7 1 is the leftmost element, right? So I have stored it in a prefix sum first element. After that, what I need to do, what I will do, I will store the prefix sum for the first row. You can see, so 7 plus 6 13, right? So you have doing that only. Matrix of 0 I have fixed I have fixed the row, only columns are changing. So I am adding the previous value stored in prefix sum with the current value. So it will be storing like this manner: 7, then here the prefix value is 13, 7 plus 6 13, then here 13 plus 3 16. Similarly it will be storing. Similarly I have done for the column as well. Here it will be storing like this: 7, here it is 7 plus 6 13. Similarly here 6 plus 6 12. Similarly it will be calculating. After that, what I need to do, as I have calculated it for the first column and the first row and first column, right? I need to fill the entire table. So what I need to do, as I have mentioned here the formula. This is the main thing, right? What you need to do, the immediate left column, and immediate left uppermost row will store the sum till that point. So we'll be adding that. Similarly, right here, see 13, 13, right? We will add, right? At next, we need to add the current element as well, right? And we need to subtract the numbers which are taken twice. Once we need to subtract it. So here I am doing the same thing. In the current prefix value, what I am doing, the leftmost one means previous row, uppermost one. Sorry, this is the uppermost one, and this is the previous column. I'm subtracting the diagonal one. You can see diagonal one, this one, because it will be stored in twice, and I am adding the current value. So this will store the entire sum for that particular point at particular point. Similarly, it will store. And at last, simply what we need to do, we need to check for the prefix table that whichever value is less than k means uh, it will be a valid submatrices. So we will return that. So this is a very easy problem. Just you need to think in terms of prefix sum, and you can definitely do this. So you got the approach. Let's move towards the third problem. Has here one thing I need to tell you that, and an m value at 100,000 only. So this is the best way to do it. Let's move towards the third problem. This is the good one. So here, what we need to do? This is the minimum operation to write the letter y on a grid. So this is the very good problem. Here my name starts with Y. Yes. So for me it's a good one. So let's the jokes apart. So let's start with this problem. So here we can see that you are given a zero index n cross n grade, right? N is odd. They have mentioned it. So no need to take care, and it is an n cross n matrix, right? And grid values are only grid contains only three values, 0, 1, or 2, right? So we can say that a cell belongs to letter y, it belongs to one of the following, right? So what need to do, uh, rather than explaining it, I will tell you the thing what they want to say. So here they want to say that let's say we are having this kind of thing, right? So you can create a y like this, right? So here what they are trying to say is that the diagonal starting at the top left cell and ending at the rightmost cell, for creating a y they have given the condition, right? The letter y is written on the grid and only if all the values at the cell belonging to the y are equal, right? Means the elements, or we can say the grid which are contributing to for making y is having must have the same element. Let's say if there are one, so all the y contains one. All value at cell not belonging to y means non y area elements are different from the element that are present in y. The value at cell belonging to the y are different from the value at this not belonging. It's simple one. So we need to return the minimum number of operation needed to write the letter y on the grid by applying one operation at a time, that we can change 0 1 means any element on a grid to 0 1 or 2. So let's discuss this is a very easy one, so I will explain it in a very well manner. So here what we need to do, here we can see that, so for making y, what we need to do, we need to move diagonally from leftmost to middle one, and then similarly from rightmost to middle one, and then the straight line, right? So on it, what I need to do, I need to check for the condition that which values will contribute to means what are the frequency of each element in this y region, right? Let's say here we are having 0, here we are having 1, here 1, here 2, right? So we'll be storing in this y region what are the frequencies of 0, 1, and 2. So here we can see that frequency of 0 is 1, 1 is 2, and 2 is 1. So here you can see that the best possible way is to uh, choose either 0 1 or 2, right? We don't know because we need to take care of the non y region as well. So here this is the y region, but this that I am marking now, right? These are the non y region, right? So they have mentioned the condition that, let's say, if I replace all the elements of y to, let's say, 1, as the frequency of 1 is more here, let's assume that 1 is the best possible way. So if I replace this 0 to 1, right, 2 to 1, right, so two operations I have here, right, but here in the non-y region I will not able to put 1, I need to put either 0 or 2, right? So I need to count for that as well. So here what I need to do, simple thing I need to apply. First, I will store all the elements, frequency of all the elements in y, right? Similarly, I will store the all the element frequency in non-y region, 0, 1, 2 frequency, right? After that, what we need to do, I will get the total, if I calculate for the y region, right? Similarly, I will get the number of non-y region elements. It will be all n into n minus the total number of elements in y region element, right? This is the non-y region elements if I need to calculate, right? So here what I need to do, if I try to replace all the y elements with 1, so here I am having two choices, take 0 and 2, means uh, only I will replace it to 0 or 2, right? So if I replace with 1, then I will try combination for 0 2, right? If y region is 1, right? Let's say y region is 1 and non y region is let's say we are having two choices, 0 2 replace. Similarly, if I having 0, right? I have only two choices, 0 1 2. Similarly, for 2, two choices, 1 and 0, right? So we need to check six conditions. 1, 2, 1, 2, 1, 2, 6, right? So this is the just a implementation problem. Create a two maps, store frequency of each element in y region, store frequency of each element in non-y region, and then apply this formula. Let's see the implementation part. I have tried to write in a very clear and understandable code. So you can see that. What I have done, grid size and cross and matrix is there. Then I have created a two matrix, two map, ordered map. One is for the y region and another one is the second one is for the non-y region. This is the visited, means I will be taking storing that which element, which grid values we have visited. Let's start with the topmost element. So here you can see that this is the 0 comma 0, right? So we will be moving in this time, right? You can see that we'll be moving in this part. So we will start from 0 comma 0, right? If we are here, right, we will need to go till n by 2 only. If you know it very well that we need to move it n by 2 to make the y properly. So here, so here what I need to do, get I and j, start from the topmost left element grid and run till n by 2. We will store the frequency of each element in a map 1 as we are traversing in the y region. I marked it at visited, increment the row and I, and count. Count for that how many grid values are contributing to y. Similarly, I start with the this part, n by 2 plus 1. This part is nothing but till this we have reached, we need to cover this, right? So I have increment a row and the column remains same. So this part is n by 2 plus 1, right? Plus 1 for row and n by 2. Column is remain same, right? So I have done this, I have traversed that, marked all the frequency of, or store all the frequency which are present in this, marked it at visited, increment the row as the column remains constant and counter value. Similarly, I start with the this part, you can say this part. So here every time the row uh, gets decremented and the column increases. So n by 2 minus 1, n by 2 plus 1 is the thing. Here you can see. Similarly, I have marked, means stored the frequency, visited, and decrement the row and decrement the column and count increases. Similarly, let's say this we stored the y region element, frequency of y region element, visited, marked. Now we have total count as well, that how many elements are in y region. So here, what I have done, I have the element which are not visited. Obviously, they are part of non-y region. So I have increment their count frequency of 0, 1, 2 in there as well. Means the region which are not, let's say this one, this two, 1, 0, 0, 0. Means I'm talking about this shaded region are the non-region. So I need to store frequency as well, as I have mentioned. So I have stored the frequency of theirs as well. Now the exact formula comes here. This T is equal to n into n minus count. It will be the total elements in non-Y region, right? Because count is the total elements in Y region. So we'll be uh, getting the total region in non-Y, total elements in non-Y region. We need to store the minimum value that we need to calculate. So the first condition that I have mentioned, if I want a 0 in Y area, means if I want this condition 0 in Y area, means I need to in non-Y region I can only try for 1 and 2, make it all the element 1 or 2. So two conditions, right? So here the first case is that for 0 in Y area, what operations we need to do? We need to change all ones and 2 to 0. So I have stored the frequency of 1 and frequency of 2. This many operations I need to do for changing 0 to 1. Similarly, uh, I can try for making 1 in non-Y region, mp2 and means 0 and 2 we will store frequency. These are the operations to make all the elements to 1 in non-Y region. Similarly, 0 in Y area we want and 2 in non-Y. I'm doing this thing only. 0 with 1, 0 with 2. 0 in Y region, 0, 1 in non-Y region. 0 in Y region, 2 in non-Y region. Similarly, we will do for 1. Similarly, we do for 2, right? Here the same thing I have done. And at last, every time I am storing the minimum value, at right I have written mini. So this is a very simple problem. Just need to create a Y in a proper manner, use the map in a proper manner, and just apply it. This is just an implementation problem with a proper understanding of this problem. You can easily do it. This is a very easy one, and no need to take tension regarding the n value, as you can, because this is just an implementation. Grid problems are mainly based on prefix type of things, as you have seen in the second question, and this type of implementation one. They need to handle these cases properly. You can definitely do this. So let's move towards the fourth problem and the very interesting one, because let's discuss this. This is a distribute elements into two array. This is a extended version of this first problem. You can see they've added a few conditions as well, and the complexity is all obviously more, as they have mentioned, uh, as per the first question, because first question is very easy one and the fourth one is the hard one. You can see that the constants are 10 to the power 5. The reason why I'm explaining that the constant are 10 to the power 5, that you need to think in terms of that only. If you try to do the brute force for this problem, it is very easy to apply brute force, but it will not run. It will ultimately give TLE. So let's think in terms of the proper manner. So here what we need to do, we are given a nums array with length n. We define a function greater count such that greater count array value means this greater count will return the number of elements in array that are strictly greater than value. Let's say I am having 1. How many elements are strictly greater than 1 in that array? So this greater count function will return. So here what we need to do. Similar thing we need to do. We have distributed the nums into two arrays, array 1, array 2, as we have done in array example question number 1. So first element I will add in array 1, second element I will in array 2. After that we need to apply operations. This is the basic step. So these three operations we can apply. Means we need to check. If let's say nums of I, let's say if a elements greater than nums of I is having a maximum, let's say 1 we have taken, right? I will take this example, right? 2133, so that you will understand this properly, because I need to try to explain a new concept here, because many people don't know about that concept. That's why they won't able to, otherwise the problem is very easy. 2133, right? 2133, 2133, right? So array 1 we are having, array 2 we are having, 2 is first element and the second element in array 2. Let's see 3. So here what we need to do, they have mentioned that if the elements greater than 3, let's say, means the strictly greater than 3 elements count, we will count 1. Similarly for in array 2 we will count. If it is greater, if the more number of elements are present here, then we need to append the element in array 1, otherwise in array 2. If let's say both are having a equal value, so here at that time what we need to do, we need to append nums of I into the array which is having a less element. Let's say if still they are having a same, then we need to append the element in nums of I. This is the thing they have explained. Let's discuss. Here you can see 3. The, the elements which are strictly greater than 3 in array 1, we can see 0. 0 elements are there, right? Similarly, the element strictly greater than 3 in array 2, 0. Now we can see equal condition is there, right? Which is a third condition, equal condition. So we need to see that whoever is having a lesser element, but here both are having the same element. So we need to append it in the first array as they have mentioned. If still there is a tie, we need to append it in array 1. So I have append 3 in array 1, right? Similarly, we go for this one. So here 3. What we need to do? We need to check how many elements are strictly greater than 3 in array 1. No, 0, still 0. Here as well, still 0. Equal, but the third condition now we need to apply this as the one which is having a lesser element we need to append there. So here 3, right? I mean our answer is 2 3 1 3, right? So append array 1 in array 2 2 3 1 3. Now you are thinking that it's a very easy one. Let's create a map and check for that. But you need to check for the both the things, right? You don't know how many elements. That means you will apply for loop here, you will apply for loop for array 1 and for loop for array 2 as well. It will not be, it will be ultimately O of n square solution, right? It will give TLE. So you need to use here a something kind of that which will store the, because we need to run a for loop for this, right? Ultimately, which will run till n, right? After that, as our constraints are 10 to the power 5, right? 10 to the power 5, you need to do the next operation in log n times only. You can't apply n. Means you need to apply log n times only. So you need to find the element which are strictly greater than 3 in array 1 as well as in array 2 in log n time only. So let's think, if you want to really try this problem, let's stop this video here and think in terms of that how we can do this. So here, hope you think that, or you have some understanding of how we can find. If you're thinking in terms of map, I think uh, many people don't know about policy based data structure, so that's why they fail to do so. So I will explain this. So let's policy based data structure. Let's wait. PBDS data structure. So here, I want to explain this. So here, what policy-based data structure do? So policy-based data structure will do, I will explain here. Let's say if you want to find the element which are less than 3 in the rightmost part, means because as you are at this index and then you need to find the element which are less than 3 in the rightmost part. So policy-based data structure do this in log n time. Here you can see that it can find the number of element less than x, case smallest element in log n time. So this is the template for it. Its implementation is purely based on red black tree. So if you need to find a element less than x in the rightmost part, what you need to do, you need to use order of key, means element which are less than 6, right? So we need to think in terms of that. So you got to know that PPDS we need to, it will find an element. But here what we need to do, here you can see that we don't want to check the element which are less than the current element. We need to check the element which are greater than that element, and in not in rightmost part. We need to check for entire array, right? So here is the catch. So here what you can do, rather than checking for the rightmost part only, right? check for the entire array. So here in policy based data structure, what we can do, we can create a pair as well, and we will pass a number 3 with its corresponding index, right? So every time if you want to check for the entire array, you don't need to pass a current index. You can definitely pass a index -1, let's say. The reason is that obviously if you pass 0, it will not take this, it will check for the this three element. If you pass 1 -1, it will check for the entire array. So every time pass index as -1 means as in rightmost part, the entire array will be covered, right? And the element which are less than 3. So here we will do this only. We are getting, if we successfully got the numbers which are less than 3, and if we want a number greater than 3, right? If we got less than 3, simply what you need to do, subtract this from the size of the array. You will get the number greater than 3. Simple maths, right? So 4 is the size. Let's say 2 is the size, whatever is the size. 4 is the size. So subtract it from the numbers which are less than. So you will definitely get the numbers greater than 4, right? So this is the simple intuition. So I will explain the code. Hope you got at the approach. Um, Here I have, this is a template for the policy based data structure. So what I have created, I've created two vectors v1 and v2. It will store the first element as I have mentioned, and second element of the array will be stored in array 2, right? Here I have created a policy based data structure. Policy based data structure, here we are using a set, ordered set. So here pair thing I have stored, as I mentioned about that pair thing, the current element with its corresponding index. Every time index will be storing as -1, right? So we will insert the first element with index 0, uh, second element with index 1, right? In the maxi count 1, it will store the number of elements in our, we can say, array 1, which are strictly greater than the current element. So this part, order of key. So nums of I is the current element, right? +1, the reason is that I am doing +1. The reason is that because we need to find a number which are strictly greater than, right? Strictly greater than. So this current element will not be included. Means this current element will also be a part of that less part, right? So nums +1 means immediate right element, let's say 3 is there, 4. So we will check that how many elements are less than 4, so that this element will also be included. If you don't want to do this, you can add 1 afterwards as well. And here I have written minus in store second value as -1. Reason is that I need to traverse check for the entire array. So this will give me the number less than that current element. If I subtract it from the size, we will get the element which are greater than that current element, right? So this is for the maxi count one. Similarly for the maxi count 2, we will get this. After that, simply need to check these three conditions, that if count maxi count 1 is greater than maxi count 2, append the element in array 1. Similar time, we need to append the element in array set as well. At that time, we put current index. Just for finding a less element, we are putting -1 because we need to traverse for the entire array. But for the putting the element or inserting element in set, we need to put a current index here. Similarly, for the second case, if maxi count 2 is greater than maxi count 1, means we need to insert the append the element in array 2, right? The third condition is that if else both are equal, so we need to check that whichever is having a lesser element. Let's say if O2 size is greater than O2 one side, means less elements are there in V1 vector. So we need to put here. Else if O2 is having a less element, O2, if equal, then we need to put element in V1 vector. And at last we need to append both V1 and concatenate both V1 and V2 and we return answer. So this is a very easy question, but you need to be aware that how to think in terms of the best data possible data structure for that particular complexity. If you haven't seen this constraint, you won't be able to come up with the optimized solution. This can be also be done using Fenwick and segmentary as well, but many that was quite difficult to implement. But this is the very easy one, that by order of key, as I have implemented here, this will able to find. So here what I have done, I have only limited thing that less than x element it can be find, but we want a greater element, like greater than x, means greater than current element, strictly greater than. So simply maths, that size of array minus lower one. So we have used the already existing concept and applied it here and able to solve this problem. So if you face difficulty, you can understand how actually policy based data structure on gigs for gigs or CPU algorithms, you can see it. You can see how actually it works. The crisp for this problem is to just this that if you have less count successfully count less than x, you can definitely count the number element greater strictly greater than x. So you can read it and try to clear the concepts related to it so that your one more concept gets clear. Hope I uh, tried to explain this in a very efficient manner, and I've tried to explain all the four problems in a efficient manner so that you can understand it. So every time read the problems carefully, see the constraints properly. This 10 to the power 5 is the biggest hint that you can't apply two for loops and you need to do a second iteration in log n times. I mean, you need to find the maximum element strictly greater than x, strictly greater than x elements in log n time only. So you can able to do this in n log n. So as policy based data structure find the element in log n, you are traversing the entire array, so n log n is the solution. Many people have done this using binary search as well. The reason I am trying to cover all these things is that this can be also be done using binary. Many people have done this, but according to me, that there might be some case they have not added in this contest, but in further future they might add, that might fail. But PBDS and Fenwick tree and segment tree are the best way to do this problem. So this is the good one. I love this problem, and because this will create a new concept, or this will people can learn new concept. So hope you got the approach behind this problem and you got the understanding how to think in terms of complexity and apply the concepts. Hope if you watch this video till this point, please don't forget to like, share, and subscribe to my YouTube channel and stay connected for more such lead code, code shape, and code forces contest analysis. Thank you. Happy coding.